Hello, my dear students and friends. Welcome you all to Chalan Malshika Physics YouTube channel. Today, in this video, we are going to discuss Newton's law about viscosity. Before that, we have to check what type of fluids that we are dealing with in physics. So, I have list main two types of fluids here. Those are ideal fluids and real fluids. Simply, ideal fluids are incompressible and they don't have a viscosity, and real fluids are also incompressible, but they have viscosity. So these are the main two types of fluids that we are going to deal. So the real fluids, again, we can classify them into two types. Those are Newtonian fluids and non-Newtonian fluids. Newtonian fluids are fluids, they follow shear stress directly proportional to the shear strain or velocity gradient. And when the case is non-Newtonian fluids, they doesn't follow the shear stress directly proportional to the shear strain. So in this video, we are going to deeply discuss about Newtonian fluids. So remember this classification because with time to time, we are dealing with several fluids in physics. So here again, Newtonian fluids, this is our topic. They are viscous, they are incompressible, and they follow shear stress directly proportional to the shear strain. So let's get more information about Newtonian fluids. What is this viscosity property? So, viscosity is the friction that we are dealing in fluids. So, when there's a relative motion between fluids, the viscosity happens. In here, in Newton's law about viscosity, we need that relative motion. Let's have a look what will happen when a viscous fluid flowing on top of the steady plate. So I will draw a diagram here. This is the viscous fluid that flowing on a steady plate. Steady plate means the velocity of that plate is 0. So it directly affect to the same adjacent touching layer for not flowing. So the velocity of that very first layer is going to be 0 because the effect from that steady plate. But when we move away from that steady plate, velocity doesn't need to be the same like 0. So it's going to be increased. And we observe the fastest velocity of that flowing on very top of that fluid flow. So the velocity is gradually increasing. Velocity is gradually increasing when we move away from that steady plate. So it's going to be lead for the separation of fluid flowing, because the bottom fluid flow have the low magnitude in velocity, and the away layers from that steady plate have the fastest velocity magnitude. So think about this with practically. When a fluid flow has several velocity, always there's going to be a relative motion. So there's a force acting on fastest layers by the small layers. So this is going to be our viscous force. When a fluid flow in different speed by separating its layers, we call that's a laminar flow. So in here, the viscosity creates the laminar flow. So laminar flow means the fluid is carefully flowing by separating its velocity. They are not going to be turbulent. So in laminar flow, they have several speeds, and they're going to separate. They are not mixing. Their velocity layers each other. Let's see what Newton has observed, and we have to learn that also. We will take two velocity layers which have two velocities. Everyone here knows the top velocity has the higher, top layer has the higher velocity, and the bottom layer has the lower velocity. I will take them as V1 and V2. So V1 is much higher than the V2. So the common area of these two layers, let's take as A, that's a common surface area. Common surface area. And the distance between two layers, let's take as a D. That's the separation distance. So there's a viscous force, or we can say a drag force, acting from the small velocity layer to on the higher velocity layer. So this is going to be our viscous force. So let's denominate as Fe. Newton told us that the shear stress among these two layers, we all know the stress is defined as the force acting on a unit surface area. This is the shear stress. So the shear stress is going to be directly proportional to the velocity gradient. Velocity gradient means the difference of velocity is going to be divided by its distance. So this is the Newton observation. So we can replace this proportional mark by a constant. The constant is neta. So that's called the viscosity coefficient, or the symbol is neta, and we call that this is the dynamic viscosity. This is the main formula that we are going to use to sum our all calculations. So the dynamic viscosity, remember that this is going to be depends on the fluid. When the fluid change, the viscosity factor or viscosity coefficient or dynamic viscosity going to be changed. So remember this. This is the viscosity stress due to viscous force, and this is the velocity gradient. So this is the simple theory that we are using in Newton's law about viscosity. Let's make it another video.